Thanks for joining. I'm back here again with Christian Bromann. Christian, how are you?
I'm doing excellent. How are you?
I'm very great. Thank you. Are you following TestMu conference?
I do. I just watched the talk from Matthias. Very insightful.
Yeah, it was good. That's good Chrome for testing, right?
Right.
Great. Thanks everyone for joining. For those of you who don't know, I'm Manoj, leading developer relations and Office of Open Source at Lambda Test. And I'm here with Christian with an insightful session from WebdriverIO. But before diving into what the actual session is, let me give you a brief introduction about Christian. Christian is a founding engineer at Stateful, measuring developer happiness every day, a bit more. He's an open source and open standards advocate, a cross-project council member at OpenJS Foundation, representing WebdriverIO. He's a driving force behind WebdriverIO project. So if you're someone who's using WebdriverIO, JavaScript-based automation tool, he's the guy to thank, and shower all your love. He's the real driving force behind it. So Christian is going to talk about component testing with WebdriverIO. There are already many component testing tools available, but almost all of them miss an important feature, right? Running the test in an actual browser. Well, you could say running tests in a virtual DOM is fine for testing. Why not just run them in a browser if you can? And we were just exactly discussing in backstage about running in browser engine versus real browser. Well, I'm sure he's gonna pick some flavors of that conversation here as well. But the interesting part is with WebdriverIO version 8, it has a new browser runner capabilities where you can actually have all this component tests directly run in your browser. Well, I'm not going to take much of your time. Over to you, Christian, with all the cool and interesting demo.
Thanks, Manoj. And welcome everyone to the session. I'm Christian, and it's good to be back on the TestMu stage today to talk about component testing in WebdriverIO. You probably heard about component testing before. It's not really a new topic. However, many frameworks have it already, and WebdriverIO as well, as Manoj just mentioned. But I wanted to show today some really interesting new features WebdriverIO provides that makes it different from all the other frameworks. And I'm thrilled to show these cool features in the live coding session at the end. But before I start, let's introduce myself. I think Manoj did already good talk to introduce myself, so we can skip over that. In this session, let's just focus on web components. And we dive a little bit, we go a little bit back and see what components are, web components are in general, what that term means, and how testing them can help us to improve the stability in our tests and increase our test coverage. We will look into the tooling landscape, what current frameworks offer and what they don't. And I hope I can convince you that component testing with WebdriverIO could be a good solution. And I will show you how to set up that in your project. And at the end, we have a little live coding session where we actually do a component test on a real component. So what are web components? I'm curious who of you have heard about that term. And probably every one of you uses web components at least in some way or fashion. The concept of web components actually has been around for a long time. There's this guy called Alex Russell who has introduced one of the first concepts and ideas early in 2011. And actually not much later, Google released a framework called Polymer, which brought the first components of web components and reusable UI components to the web. At that time, like back in the days, JavaScript applications were mostly massive monolith, often using a model view controller pattern written in frameworks such as Backbone or Marionette.js. And people became very frustrated to maintain this kind of application because they would go fast and become very complex. So with frameworks like React.js, Polymer, or Angular early on, a new era of front-end development really has kicked off that try to encapsulate UI bits into reusable components that can encapsulate styles and functionality to be used across your application. So when we talk about components and reusable UI components, we kind of have to differentiate two things here. The one thing is the idea of reusable UI components, which has been implemented early on by React before even the standard has been landed in browsers. And then we have the web technology called web components, which is the actual standard. So there's basically the same idea, but two kind of different things. And I will explain that in a second. Today, it's very awesome to see so many UI components popping up left and right that allow you to write reusable web components. We have frameworks like lit-HTML, stencil.js, React, Vue, and Svelte that all allow you those to do those kind of things. At a very basic level, web components are a few specifications and APIs that are part of the HTML specification and that allow you to write custom elements and components. The main technologies in itself are custom element specification. You see on the left, we create a custom HTML element where we have a class in JavaScript that extends from the HTML element. And we attach or we register that custom element to a registry to be able to emulate to use it in our application. Another concept of web components is the shadow DOM, which is a smaller, more self-contained scoped DOM that allows you to encapsulate CSS and markup into components. And lastly, there's the idea of HTML templates that allows you to define HTML and inject it into a page using JavaScript. So those HTML fragments basically are not immediately rendered when the document is loaded. It can be rendered and attached to the DOM, for instance, the shadow DOM, using JavaScript. And as you can see, a very basic web component does not need any framework or build tool or bundler. There's just the basic JavaScript and web APIs that allow you to write really nice reusable web components. But if you have used frameworks like React, obviously, you probably never have written a web component like this. Here in this example, lit-HTML kind of like is a framework, a small superset on the actual web APIs that makes it a little bit more easier to write those web components. There are other like similar examples that provide you a really small superset, for instance, the Enhance framework or Stencil.js. And these are very useful if you really want to build a set of UI components that you want to use across your organization. And no matter if you use React or Vue, Next.js, or whatever is out there, those are at the end basic web components that you can inject in your framework no matter what it is. So these really, UI frameworks in a sense really make it very easy to write shareable UI components. But there's also React and the more mature frameworks like Vue and Svelte that has been allowing to write reusable UI components much longer, even before the standard has landed in the browser. And they kind of achieved this in a different way by using JavaScript and things like a virtual DOM to make modification to the DOM in the most effective way. And things like style encapsulation has been achieved through different techniques. Now, I think the majority of the folks here, have been using web components, already testing it, and we see that when we test those components or our application in general, we need to ask ourselves, what we are actually testing. Does our feature that we are testing actually modifies the whole application state, or requires a specific third-party service like an authentication service? Over the years, we have established so many ways we can test our application to ensure we do that in an efficient manner. And we have created best practices around that. But as technologies, changes, we as communities should also go back and think about, should we test our application different now with these new technologies that have been coming up? Which brings me to testing principles. I think there's not a talk at all where I don't bring up this testing pyramid, a very interesting and important concept. And for people who don't know, it groups software tests into buckets of different granularity. And while I still fully agree with the principle itself, I realize that it's easy to get wrong because we just get overwhelmed with the amount of different tooling that's available out there. I often personally see myself getting very comfortable writing WebdriverIO tests that give me a lot of confidence, but it makes the top part of the pyramid much bigger than it should be. At the end of the day, as a tester or as a developer, we should make sure that we write mostly unit tests because they are fast to run. We should write a lot of integration tests as well, and just like a little end-to-end test to make sure that all our components and all our vertical elements really play nicely together. Because at the end, these unit tests, they went fast. They don't give us a lot of confidence, though. While at the other end, end-to-end tests are nice to write because they give us so much confidence, but they can be brittle and flaky here and there, and they're expensive to set up. So as our way and processes how we build web application today has changed, we should also visit our approaches and how to test them. People like 𝐂𝐛𝐨𝐮 are on the forefront of creating new principles around that, and he created this idea of the testing trophy, which I find very interesting, which really emphasizes the question of return of investment. So what do I get back as a value for writing an end-to-end test or a unit test? Again, end-to-end test gives us a lot of confidence, but might be expensive and brittle. Unit test, not so much confidence, but a faster run. This concept, the testing trophy, really puts more emphasis and more focus on the integration level. And this is really an interesting concept because it allows us to really go broad and say, there are some features that I want to test more end-to-end like, and some features I want to more test on a unit level. And integration tests give us like a little bit more, it's like a nice middle ground of complexity, confidence, and execution time. Let me show you what I mean by that in a concrete example. Let's say we have a login application or a login form with a login component. And so we say this login form that sends a request to a backend, and the backend is connected to a database that can use the credentials to authenticate the user. Now, I think every one of us has been written an end-to-end test for that, right? We would, take our application, we would use a valid user credentials and invalid credentials and see if we get logged in or not. This is all great, and I think we should not change from that. However, we can increase our coverage by, putting more focus on the integration level. That means, in particular, we can use a lot of component tests for our UI component, the login component, to make sure that all the backend responses that eventually could come back are really, are handled well, like error messages are being displayed nicely, and so on. And then on the backend side, we can run just a bunch of API tests to make sure that all the user input that could potentially go to the backend is handled correctly, and that we don't run into things like an SQL injection. To top things off, let's imagine our login component and login application it should run on a mobile tablet. It's a web application running on a mobile tablet. End-to-end tests can be very expensive to run all these various of tests that test different kind of input types on an end-to-end level. That can be very expensive and brittle. But if we just test this on the component level, it can be much faster because we don't have to spin up the whole application. So you might think now, well, that sounds great. I think writing more integration tests, writing more component and API tests sounds great, but where do I start, right? Which are the tools that I should use to do all of those things? And I usually would recommend you look at your existing stack that you're using and that you feel comfortable with, and see what this stack recommends you to use as additional tooling for testing. I've done this in terms of component testing. I went to all the frameworks, looked on their docs, and see what they recommend. In the early React.js documentation, there was a section saying that if you want to test React components, use the Jest JavaScript test runner, which is very popular, using with JS DOM as a DOM emulation. Now, jumping to today, I still haven't found on the new React docs a way to test React components. So that is a little bit weird. I don't know if React developers test their components, but there's no guide on that. Other frameworks are a little bit better. Vue has great documentation telling you which framework to use for unit, component, and end-to-end tests. But looking on all the other frameworks, I see a very interesting common pattern, which is that they all kind of recommend you to use an arbitrary test runner, being a Jest, Vitest, or Mocker as a plain framework, combined with JS DOM. And I find this as a not really great idea. For people who don't know JS DOM is a pure JavaScript implementation of many web standards, notably the WhatWG, the DOM, and HTML standards to be run in Node.js. Think about it as a web browser in Node.js. And it's actually meant to be used for testing. Actually, their docs say that JS DOM is there to emulate enough of a subset of a web browser to be useful for testing, which is great, right? But I feel like using JS DOM for component testing is kind of like using an old Macintosh for graphics work. It kind of does its job, but it's not really a modern thing to do because we can just use a real browser to test our components, and JS DOM just doesn't do it. And there's very reasons for that. there are a bunch of caveats that JSDOM comes with that for some people are not really important, but at the end of the day, it makes a difference, in my opinion. When interacting with elements using JSDOM, since it's an emulated DOM interface, it's not a real user interaction. And I can show you what that means in a second. Furthermore, JSDOM is missing some very important modern web APIs, which is the fetch API that has landed in all browsers. CORS is missing, as well as module scripts. Lastly, JSDOM has really difficult problems to use canvas. It cannot support pseudo states like hover and active. So it's difficult to test components that have a hover state since you actually don't render anything. It's just a virtual DOM. And the actual implementation of all those web standards may differ from browser to browser. So it's not really cross-browser testing. It might still have, but you might still find bugs in other browsers. Also, if you ever have tried to, or if you ever done JSDOM component tests and you wanted to debug what's wrong with your component, you cannot just open the DevTools interface. What you get is you can print the screen, which will print your virtual DOM, and that's about it. It makes it really difficult to kind of like debug what's going on. And going back to the idea of, as a tester, we want to use the environment that comes as close as possible to what your users use. It starts with you don't want to use on Chromium because it's not the same as Chrome, as Matthias has mentioned in his talk earlier. And using JSDOM for component tests is the same way. It is not the same as a user interaction. And you can see that when let's say we have a scenario where our component, for some reason, sets the style of a login button. We have a little login form here. It sets the style of the login button to be hidden, like the visibility hidden. Now, if you now want to click with, using Jest or Vitest, using JSDOM, using testing library, for instance, if you were to click on the element, the click event would be emulated on the button, which is not there, but the element click would still be registered by your component. So that means, in reality, your user could not click on the element, but your test would still work, even though the button is not there. A similar example is if you give your button a height of 0. And I know this is kind of a made-up example, but I've seen in real-life use cases where those kind of things happen. If you have an dynamic component that removes the login button for some reason, and you want to still click on it, those kind of things can actually happen in real life. There's another example that I try to do is like what happens if an element is on top of that button. Still, in a JSDOM environment, that doesn't really matter because an element event is triggered on the actual DOM node. And it doesn't care about whether or not a user can actually click or the element actually receives the click. Other frameworks, like the WebDriver-based ones, Nightroach, WebdriverIO, Playwright, Cypress, they all have implementations that verify if an element is interactable. And they run this process, this check, every time you interact with that element. And then one interesting use case that I tried is what happens if you just move the element completely out of the viewport in a way that it cannot be, that the user could not scroll to that specific element. Here, what I found out is that Cypress and Playwright actually have very aggressive algorithms that just will move back the element no matter what. And that was interesting to see. So that also not actually really shows the reality here. Actually, only WebDriver, their algorithms make sure that even if you cannot scroll through an element, you will see that as an error, and you will see this, I think, popular error in the WebDriver space, which is like element is not interactable, which is in many ways it's like a true statement, and we should take this error seriously. Last but not least, there are some features that you just cannot do in JSDOM-like environments, which is the scroll action. Since you don't render anything on the screen, even virtually, you cannot scroll anywhere, which sometimes is a problem. And especially for more advanced user interactions, when you build mobile components that use like a pinch zoom kind of thing. Here, I see only WebDriver frameworks like WebDriver, Nightroach, the ability to do so because they have a really the WebDriver standard comes with a really powerful Actions API. And one of my favorite features when it comes to component testing and testing in general is mocking. I find mocking the most useful thing because you want to really make sure that you test the things that you care about. When it comes to a component, I don't want to make network requests, because that is just not part of my component. I just test that a certain interface has been called correctly, and then everything after is part for a different test. And so with JS-DOM and running in Node.js, you can actually emulate and mock modules, and Vitest and Jest provide a great interface. We have brought this with WebdriverIO to the browser as one of the first frameworks out there. So you can do actual mocking in a real browser, which is just the missing piece of all the frameworks that I've found out so far. So that all sounds great. Maybe you give WebdriverIO a try when it comes to component testing. The question is how you would set up WebdriverIO, right? There's this one unique command that you can use. It's the npm init command, and you call npm init at latest, and then you provide the directory to your project folder. And what happens here is that WebdriverIO will install a wizard for you that will ask you a variety of questions to make sure it set up the project correctly. And we have, one of the first questions will be, what do you want to do? Do you want to do end-to-end test, component test, desktop test, electron test, whatever it is? If you select component test, and then you can choose a preset of one of the frameworks that are out there, Preact, Svelte, Vue. There's, I think, 6 or 7 available frameworks that we support, that WebdriverIO supports. It also asks you whether or not you want to use testing library, because testing library is a really great framework to stage a component and remove it afterwards, and for selecting an element within the website. So we ported testing library to the browser to be run in the browser, and you can use that as well. And then at the end, you get a project with a boilerplate component to get you started. In an ideal case, you should have a passing test immediately. We will see how that looks like in a second. If you run component tests, then everything looks a little bit different. You don't spin up a whole website. What you render on the page, what you stage on the website, on the browser, is your component that you want to test. And so if you run component tests in WebdriverIO, you will see on the left side the components that you're testing. Excuse me. On the middle side, you get a reporter. And on the right side, you get the Chrome DevTools locked and loaded already for you. That means that within DevTools, you can run all WebdriverIO commands, which really help you to basically prepare your test and copy-paste whatever you've written there into your test. So I really like to use the DevTools to write my WebdriverIO commands, because I can fiddle around with the component that is rendered in the browser. I can see if my hover commands work correctly, and especially useful, DevTools is especially useful for finding elements, because I can go inspect the DOM, and DevTools has a neat feature that allows you to inspect the accessibility. So you can inspect an element, find out what the accessibility label is, and use the accessibility label selector for WebdriverIO to actually find the element. So this makes writing tests a whole lot easier, because I can just fiddle around until my test works and my automation steps work, and I can just pass it right into the test. But enough GIF animations. Let's go to a live coding session. Use the rest of the time for live coding. And for you to follow along, you can just join me by using this bit.ly link that I have there. And you can pick one of those frameworks that WebdriverIO has support for and run the example with me. So if you're a React user, you can use bit.ly WDIO minus React minus demo. And I will choose React myself, and I will just really quickly change this shared screen. So if you haven't done yet, make sure to, let me share the whole entire screen now. So let's do the React example. So you type this in the browser, and what happens is that it pops up a little an alert to ask you if you want to open it in Visual Studio Code. And so what it does, it will check out the example repository into a new window, and then it will open the React example for me. And depending on which framework you choose, you will end up in a different folder. So I will go ahead and use this runbook to install my dependencies. In case you wonder, this is RunMe, one of the extensions and VS Code extensions that I'm working on as part of Stateful. And so we have installed these dependencies, and now we want to test our login component that we've seen in the slides. It's a pretty basic React component. That has, some markup and username, password, login button. And when it logins, I have a little API that basically emulates a login request. And we want to write a component test for this now. So I will start writing a new file. You can see the solutions already there, but I'm going to start with something fresh. And for the beginning, let's just verify that we're actually running the test in the browser. So to do so, let's say my component test should run in the browser. And one way to verify that is just to use a web API that is only available in the browser. We can go ahead and say, okay, let's check the user agent. Then we go in our WDR config, and you see here, there's the new runner being used, the browser runner. And the preset is set to React, so WebDriver will configure everything correctly to render your component correctly and stage your component. So we remove the headless part because we want to see what's going on in the browser. And one thing to make the logs a little more clear, so then we set error here. I think that should be it. So in our runbook, we can go now target our login test. Let's just run that. So this will execute one browser. In the background, we use Chrome for testing to spin up the latest Chrome that is available, or the stable version at least. And we can see that we get Chrome 118, which is the Canary version that I've installed on my local machine. But we can go ahead now and say, okay, well, I don't want to test my component in Chrome. I want to test my component in Safari. So we can just change the capabilities. Let's rerun the test. And that will now set up Safari for me automatically and see the tests are now being run in Safari. And I see Apple WebKit Safari. So I can use these component tests to really do cross-browser, not only Chrome, not a Chrome engine or Chromium engine. I can actually test my components in a real browser, which is awesome. So I will stick with Chrome for now. And what I'm going to do now is I modify my test to render my component and stage my component. For that, I recommend to use the testing library. Again, I mentioned that before. It's a great framework to stage your component and remove it after your test has been finished. And so what I next need to do is to import it. And so we see here it's a default class. We import that. So all the stuff that I'm writing here is being executed in the browser later. So what we do here is that we call the render method, and this is JSX, so that means I can put my login component right in there. Since it is React that I'm writing, I can just import React and it understands it. So that's great. For now, let's say, okay, I want to just see what has been rendered. And I do a little pause here, 5 seconds. This is now an async function because I use browser APIs, the WebdriverIO APIs. And so in my runbook, I will rerun my test. And now I should see my browser popping up and rendering my component in the browser. That usually should not take as long. So we'll see if I might be my internet. Maybe I should. Oh, there we go. There we go. We have our component rendered, and then my test will pass, and all is good. That's great. Let's start writing our end-to-end test. For that, I recommend to use the watch flag and just iterate on the component that is being rendered on the stage. So here I just point to my spec that I want to test and just call the same command with the watch flag And now what happens is that the browser will not shut down. It will stay alive, and I can just debug directly in the browser. You will see that Chrome starts with Chrome DevTools already enabled, so you will not miss any network requests that might happen as your component loads. And so now my test will run and finish, and I can go ahead. Actually, it disappears because the testing library cleans up my my component. So in order to have not the test being finished, I will just add a debug command, and so the test will now stale, and I can go ahead and inspect what's going on here. So let's start with a simple example. Let's start. I want to verify that if I put invalid credentials in here, I should get an error message here. So to do that, let me inspect the element. I see I have an email form here, and again, I use the accessibility tab to see, okay, this is accessibility name email. Let me check for password, it's password, and then I have a login button that is login right here. So with identifying the accessibility IDs, I can now go ahead and write my test. Let's say I want to click on an element that has an accessibility. Okay, we'll just restart. That has an accessibility selector called login, and we say set value of hello world. We write that. It does not find it. Let me inspect the element again. So maybe just take a different one. Just take an input with a name email. I'm not quite sure why this didn't work now, but let's go ahead. There we go. We can do the same for password. That's the wrong. Password. There we go. And then we want to click on a login button. Let me try the accessibility label for that. Login, click, actually. Okay, great. So we have a password, we have a password, and then we click on login and it fails. Let me now copy those over, remove these log levels. I can copy those over in my test. Bring it up. And now I want to inspect that, these input elements have the class, which is invalid. Let me check for that they have the proper class that makes the element show red. And to do that, we can use our expectation library, which is, I want to see, an input with my email, with an email name. That is right, to have element class is invalid. ChatGPT knows, and I call this, and now my tests are passing. So it's a really interactive way with the browser to test the application, to set up the right selectors, and to go from test to test. Let's do a successful, actually, no. One problem of this test is still that we use the API, and we don't want to include our backend for our component test. We want to test those separately and increase coverage for that. So I will stop the test for now. And in order to mock the API, I can do two things. Either say I want to mock the global fetch method. That's possible. I can also just say I want to mock the whole file, and we're going to do that exactly that. To mock in WebdriverIO, you can import the mock function from the WebdriverIO browser runner. And to mock a function or mock a file, you pass in the directory or the URL of that function, and then you pass in the function or URL of the file, and you pass in the function that returns your expected interfaces. So in here we have a named export called login. So we want to make sure that we export that as a mock. And instead of actually running the function, we would just say, okay, return an error, and actually do it correctly and say, we say this function is the mock function that resolves in an error saying invalid credentials. So if we run this now, let's do that. Let's see what we see as a change now. Ideally, we don't make the fetch request anymore because we have mocked out the whole file. So let's see what happens. There we go. Actually, still the browser has been called, interestingly. Let me see, take another look in my test. That looks actually right, unused label. Oh, okay. So we have to do this. Return. This sometimes gets a little fizzy. There we go. Now we have a passing test, and we don't have any networks requests going on in our browser, which is awesome. We actually can go further now and say, we want to validate that my login function has been called correctly. So what we're going to do is now we import the mock function. This might be confusing in the first view, like we import an actual file, but what you get is actually this here. You get the mocked version of the file back. And then we can assert what we have been called here. We can say, hey, we expect that our login method has been called once. And we also expect that our login method has been called with our particular email from the test and the password. That will be this one. Let's make this nice. There we go. It passes. Just to validate, let's add an error, and you will see that the email was not the one that we expected. Now let's say we want to have a successful case. Should log in successfully. And here, what we're going to do is we change the mock to actually return a successful response. And to do this, ChatGPT already helps us. For this, we need to we have some type issues here. To get the mock version of our function, we do this, and so we get better typing. And in this case, we just say, okay, it returns a token. Let's just ignore that error for now. And so we run our function again. We set our user credentials, and we let's make this async. All the commands are still async because they actually run in Chrome driver. WebDriver sends them from the browser to Node.js, executes them in Chrome driver, and sends the results back to the browser. And now we should expect that our email should not have an element class that is invalid, nor should our password. Pressing save, and there we go. We have a successful login without actually reaching the backend. We can extend our test now, but this should be good for now. I want to show one last feature, which is test coverage. It comes out of the box for all frameworks that are out there. To enable it, a simple coverage report, coverage flag should be needed. So you add this to your browser runner configuration. And let's say we want to make sure that we cover 100% of our lines that we have in our test. So let's add that. And we run our tests right here. So this now runs with coverage enabled, and it will verify that we it will collect all the lines that we have executed we run our component in. So whenever we miss a line, it will tell us, hopefully. There we go. So now we see our tests have passed. And and our login function as well have passed, but we are missing our API, which is okay because we have no unit test for that, but we can now make sure that our login component is actually fully covered. All right, let me get back to here, sharing, and go back to the slide for the last screens. Before we close up, I hope this example showed how easy it can be to write component tests and how interactive it can be with, debugging and working with the browser directly and using your, already familiar dev tools. What's next when it comes to component testing in WebdriverIO? We want to support more test runners. Right now, WebdriverIO comes with Mocker, Jasmine, and 𝐂𝐴𝐻𝐿𝐴𝐻𝐿. We want to soon allow you to run Jasmine and 𝐂𝐴𝐻𝐿𝐴𝐻𝐿 tests in your browser. We want to add some snapshot testing, more particularly for doing snapshots on DOM nodes to increase the test coverage, or to just have a simple assertion to cover a whole tree or a whole component. But we also want to do this for image snapshots. And then we want to provide even more support for more frameworks. Like right now, we don't have good examples and documentation for AngularJS. We want to fix that in the future. If you have any suggestions what we could else do in component testing, you can always reach out on Discord and in the WebdriverIO community, where you are always welcome. With that, I think we're good in time, and I can go back to answering some more questions. Thank you so much for attending.
Thanks, Christian. That was, again, a fantastic and insightful session, completely on component testing. I was curious, how does really the code coverage works? That was new to me.
Code coverage works. So in the backend, WebdriverIO uses Vite and to stage the test and to stage the test. And Vite has coverage reporting embedded, and so it's just one of the features that Vite comes with. And so basically the JavaScript code that is being served to the browser is instrumented, and we can fetch which lines have been executed through that.
Right. Is it only for component testing at the moment, or I think there's a question from the attendees as well? Can that be extended to other tests? Obviously.
Yeah, it's currently only for component testing. However, once WebDriver BiDi is further along and more features are enabled, I'm definitely sure we can also enable that for end-to-end testing.
All right. I know I can chat with you anytime. I'll shut my mouth and try to pick a question from the Q&A. There's a question from Giant. I'll let you read for yourself. And
could you discuss the role of mocks and stubs in component testing with WebdriverIO and their impact on the test speed and reliability? Absolutely. For me, component mocks and stubs are the most important part when it comes to testing. I want to decide my own whether or not I want to test a component that includes other component, or I want to say I just don't want to have them and exclude them totally. And so mocks and stubs are essential when it comes to writing tests that are stable and fast, because sometimes when your component depends on a different component that requires some computation or that loads a lot of things that you don't want to, and you don't care in your tests, you want to stop and mock this out. And again, WebdriverIO, with WebdriverIO, you can do that right in the browser for all frameworks that are out there.
Awesome. Probably one last question before we wrap up the wonderful session. Question from Sergey. What should be the scope of component tests? What kind of validation should be done?
I think every feature that your certain component, and it can also be if you have like a navigation component that includes many other subcomponents, but wraps up your navigation part, you can all use this as a component test and test your navigation as a whole. And so it's really up to you how you want to define your scope, and it's depending on the component that you're testing, how much of other components you want to include in that. If you can test them by encapsulating them, and if you can mock all the dependencies out, then it makes sense for you to increase the scope of your component test to give your tests more confidence, because you test just a broader stack of your application and your front-end part. So it's really up to you, but the nice thing about component testing is that you can really define that yourself and based on your situation, which is really nice.
That was some nice piece of advice for all the test strategy. With that, time that we wrap up the session. Thank you so much, Christian, and for everyone sticking around. We will start up a thread in the Lambda test community where you could ask questions, and Christian is very active in Selenium Slack channel and WebdriverIO Discord and Twitter as well. So thank you everyone for joining, and Christian, thanks again.
Thank you all for having me. Enjoy your conference.